Good morning to everyone. Now we are discussing about VLS engineering. Today we are discuss about the following content, that is introduction, integrated circuit, classification of IC, what is VLSI, advantages of VLSI, applications of VLSI. Before discuss about above content, everyone have some doubts. That is why we are studying this subject. What is the importance of this subject? First, I want to clarify this doubt. We know that we want to purchase any electronics gadgets like a mobile phone or laptop. First of all, we are asking what are the processors are using on that system. It means that the performance of the that system depends upon the processor. That processors are manufactured by with the help of VLSI technology. We know that the first generation computer size is look like a room, but now the size is minimized. How it is happened? These things happened by with help of VLSI technology. Now we can discuss about introduction. In the earlier days, all electronic systems are manufactured with the help of vacuum tubes and some electronic circuits. The vacuum tube's size is large and require the more power and unreliable. So we are replacing these vacuum tubes by transistors. That is the reason after invention of the transistor, the dramatic change occur in the electronic systems because all the transistors are inserted or are fabricated on a single silicon crystal chip, that is the processor. With the help of these processors we are manufactured the electronic systems. These systems performed good operations and we are minimize the size of the systems. Next, we are discuss about IC. For understanding of IC, I am consider one example. We want to verify the truth table of AND gate. First, we want to construct the AND gate on the breadboard with help of BJT. For the construction of AND gate, we can require two BJTs and two resistors. This whole setup constructed on breadboard. Additionally, we are giving the power supply, and based on that, we can verify the truth table of AND gate. But in the DEC lab, we know that we can verify the AND operation with the help of IC 7408. It's clear. Compare these two examples. The same AND operation we are verify on the breadboard with help of BJT with help of IC. But in the IC have the four AND gates. For example, you want to get the four AND gates with help of BJT, we can require the 8 BJTs and 8 resistors. So all the components are inserted on the breadboard. Automatically, the circuit complexity is increased. We can avoiding the circuit complexity simply we are using the IC 7408. It means that this all the BJTs are and resistors are fabricated on a single IC. So IC is a circuit where the discrete components such as active and passive elements are fabricated on a single silicon crystal chip. Observe this figure. So this is the single silicon chip. This single silicon chip in this silicon chip we are inserted the active and passive elements are fabricated or inserted on this single silicon chip, and this silicon chip is connected to terminals with help of these connecting wires, and this whole setup is covered by this air cover because the air has some of the dust particles can break down these connections. So we can avoiding these problems. We are covered by this envelope cover. The ISIS can be classified in three categories. First one is on the base of the fabrication. Second one is the scalar level of fabrication. Third one is the application. Based on the fabrication, ISIS can be classified in two types. First one is the monolithic IC and second one is the hybrid IC. The word monolithic is from the Greek word monos and lithos, which means single and stone. Mono means single, it means stone. It means that this IC fabricated on a single silicon crystal chip, isn't it? Just you can imagine, this is the single silicon wafer. In this single silicon wafer, we are fabricated single silicon chip, isn't it? That is we can call the monolithic IC. And on the same silicon wafer, we are fabricated the many number of chips, and these chips are interconnected by connecting wires. That IC is called as hybrid IC. Clear? Compared to these two ICs, hybrid ICs execute multiple instructions at a time, because you can execute the multiple instructions on the monolithic IC. It will take some time for execute the instruction step by step. But on the hybrid IC can accept the multiple instructions at a time, and it will process and it will do the responding output. This is the hybrid IC. So we are giving a more priority to hybrid ICs. And the second category is the scale of integration. Scale or level of integration means how many number of transistors are fabricated on a single silicon crystal chip. It means that based on the transistors only we can classify the ICs. So the first one is the small scale integration. SSI means small scale integration. So this is the first generation IC. This is introduced in the 1964. In the small scale integration, we are fabricated only 1 to 10 transistors. With help of this transistor, we can getting only 1 to 12 logic gates. With help of this 1 to 2 logic gates, we are performing gates and operations. And the second generation is the medium scale integration. It's introduced in 1968. The technology was developed by integrating the number of transistors of 10 to 500. With help of 10 to 500 transistors, we can get the 13 to 99 logic gates. We can get it. So these many gates can helpful for perform the counters, marks, adders, and operations we are able to perform. Third one is the large scale integration. This is introduced in the 1971. The technology was developed by integrating the number of transistors of 500 to 20,000 transistors are fabricated on that IC. So, with respect to these number of transistors, we can get the 100 to 9,999 gates. We can get it. With help of this, we are perform the 8-bit microprocessor, RAM, these we can design in this large scale integration. Fourth one is the very large scale integration. This is introduced in 1980, and the technology was developed by integrating the number of transistors of 20,000 to 1 lakh transistors are fabricated in a single silicon chip. It means that in this single silicon chip, we are fabricated nearly 20,000 to 1 lakh transistors are fabricated in this silicon chip. So here we are getting nearly 10,000 to 99,999 gates we are obtained. So these many gates can helpful for 16 to 32-bit microprocessors and other we can get it. Last one is the scale integration. This is introduced in the 1984. The technology was developed by integrating the number of transistors of 10 lakhs and more. And here we are getting the logic gates 1 lakh transistor, 1 lakh logic gates we are obtaining on the single silicon crystal chip. This is helpful for the special purpose process. And third one, applications. Based on the applications, ICs can classify into two types, that is the analog ICs and the second one is the digital ICs. If the IC is used for amplification purpose and power amplification purpose, that IC we can call as analog IC. If the IC is used for digital electronics for processing the binary signal is called as digital ICs. The next, you can observe this graph, how the VLSI technology is minimize the size of the chip. In this figure, on the x-axis we can take the time, and y-axis we can take the minimum future size in micrometer. It means that at this duration, the size of the microchip is 4 micrometers. And when we are keep on increasing the time, the size can be minimized to 0.1 micrometer. Mean that the size of the microchip is exponentially reduced. But now we can use the nanometer. The size of the microchip is what? Nanometer we have achieved. So just you can imagine how the VLSI technology can helpful for minimize the size of the microchip. And the next one is what is VLSI? Very large scale integration is the process of creating an integrated circuit by combining thousands of transistors on a single silicon crystal chip. VLSI began in the 1970 when complex semiconductors and communication technologies were being developed. It means that basically the technology getting more growth after invention of the transistor. Before that, we are not getting any growth in the VLSI technology, isn't it? Because with the help of VLSI technology, we are inserted the more number of transistors on a single silicon crystal chip. Just you can observe this table from observe the years. From these all years, the number of transistors fabricated in a single silicon crystal chip also gradually increase. So the number of transistors are increased in the single silicon crystal chip. The performance of that processor or that silicon chip is good. Clear. So this is the evaluation size. This is the VLSI and advantages of VLSI. The VLSI is helpful for reduce the size of the circuit. And I gave it example what same and operation performing the breadboard with help of BJT will take some complexity, but the small IC do the connection of breadboard give a small output not to connecting wire, then we can get the output. Means that from this complicated circuit can be reduced, minimized. Reduce the effective cost of the device. I hope maybe you take 8 transistors and some of the resistors and the amount is what some like getting wise the amount is large. So with the help of various technology, directly this all the transistors are fabricated on a single silicon crystal chip, and we can minimize the increase the operating speed of circuit. So definitely with the help of various technology, we can increase the operating speed. Requires less power than discrete components. Definitely in the various technology and one another advantage is definitely we should try for minimize the size. And next one is higher reliability. Last one is occupies a relatively small area. Means that definitely it will if we are minimizing the size then automatically it will occupy the very less area. So the advantages. And last one is the applications of VLSI. Voice and data communication networks. It means that for example you will take the mobile phone. So simultaneously we are transfer and we are receiving the signal. But the mobile phone doesn't have the processor built with help of VLSI. Second one the digital signal processing. Like computer, if you will take the RAM, ROM, and all these peripherals are all these peripherals manufactured by the processor. The processor built by the VLSI. Commercial electronics, like we can take them like digital cameras and all some other electronic gadgets where with the processor. The processor built again VLSI. Automobiles and medicine and many more means. Medicine point means you will take the ECG and all some equipment internally have the processor. That processor is again built with the help of VLSI. These are the types of the VLSI technology. Thank you.